Oh, greetings, everyone. Welcome to Trigonometry. With this session today, we're going to be looking at how to use trigonometry to find the missing sides of a triangle. In order to do so, I'm hoping you've seen the video about how to label sides already, so that I can move quickly through that. And secondly, this is more just a reminder that Pythagoras figured out a long time ago that a squared plus b squared is equal to c squared, meaning how to connect the two short sides and the one long side of a right triangle. That is the type of triangle that we're going to be working with. So if we're looking for sides, we can definitely use the trigonometry that I'm going to show you, but also keep this good guy in mind. Now, we're going to work through a problem, and I'd like you to pay attention to how it's organized. And if you use this approach, it can work for other styles of questions as well. So let's suppose that we have a triangle that looks like this. It can be like that, and like that. All the triangles we work with, to start with, they're going to have 90 degrees in there. Now, what we'll do is we'll say that this angle down here is 30 degrees. We'll say the hypotenuse, the long side there, is 12. And for this question, what we'll do is we'll figure out what this side is, the y side. So that's the question. How long is y? Now, I got these steps here. I'd like you to follow them. If you do so and super careful, you'll always get these right. So, the first thing is to circle the angle that we're working with. This one's 30, that one's 90, and by default that one's 60, and the invisible one there. Okay, but of the ones we're going to use, it'll never be 90, by the way. It'll be one of the small ones. So circle the angle that we're working with. Just a dotted circle like that. Second, it is around this angle that you label the sides. Because if you saw last time, if you change where the angle is, the labels change. That's why we circle it. Kind of keeps it in location. So the long side is always the hypotenuse. The other side that's making the angle is the adjacent side. And we are going to short that to a DJ, but just to write it there for now. And then the remaining side that is away from the angle is opposite. And I am going to shorten that just because of the lack of real estate we have here. Next, what you want to do is you want to take a look at the numbers that are given in the question and the letters that we're looking for, meaning the sides that we know and the sides that we need. In other words, what we have and what we need. You make a note of these things. And these could be angles or sides. So for now it's going to be the sides, because what do we have? We have the hypotenuse, which is 12. And actually you don't even need to put the 12 in at this point. We have the hypotenuse, and what do we need? The opposite. The fourth thing is to invoke SOHCAHTOA. Say that magic word. And then what we have to do is we got to take a look at our earlier step, what we have and what we need, and decide which one we're going to choose. Which one means which trig function. Are we going to choose sine for S for sine rather, C for cosine, T for tangent. Alright, so because we have hypotenuse, that means this one and this one. And because we need the opposite, we got that one and that one. Well, the one we want, the trig function we select, is the one, of course, that has both of them there. So that means we're going to have sine with opposite and hypotenuse. So sine of what? Sine of some angle. It's going to be opposite over hypotenuse. And number 5 then, going over here. It's now just subbing in the values and working out. Sub in the values and do the algebra that you need in order to get to the end. So the next step, this is going to look like sine of 30. And put the degrees up there if you don't mind. Otherwise it's radians, which is something different. Kilometers versus miles, pounds versus kilograms, it's just different. So sine of 30, the opposite side, in this question it is y. And hypotenuse in this question is 12. And I'm saying in this question because really all of these steps can apply to any other triangle with numbers and variables and such. But number 5, we get specific. What's going on in this question? Put in the values, you work it out. So in this case, 12 is on the bottom. So of course, multiply both sides, top and bottom, by 12. And you will, you get this. Now there's people in grade 10 in this group, people in grade 11, 12, perhaps others. Sine of 30 is 0.5, which you may or may not know. So I'll give you to that for free. If you don't believe me, you can test it with your calculator. So we get 12 times 0.5, giving our needed y value of 6 at the end there. Alright, so steps are circle the angle to begin with, just so there's no confusion about where number 2 goes, all the labeled sides. Next, take a look at the numbers you have, the numbers you need, and then use that in the next step to figure out which trig function you're going to use to set up the equation. Once that's in place, sub in the numbers and do the algebra carefully and correctly. Hey, and enjoy the success of finding the correct answer at the end. Okay, here's another example. Got something like this. Finding sides. Say that's 60. Given is 90. Say this is 8. And we'll look for this side instead. So x is equal to what? Circle the angle, even though it seems silly, I know. But we'll get along if you do. Next, label the sides. hypotenuse, a DJ, and then opposite. What's next? Label the sides. After that, halves, have-nots. No, have and need. So what do we have? Well, we got the hypotenuse. What do we need? We need the adjacent side. Okay. So then looking at SOHCAHTOA. SOHCAHTOA. Yeah, you can just check it out. Hypotenuse for those, there and there. Adjacent, there and there. So this is the one we want. So we're going to set up our equation with cosine. Cosine angle, cosine of an angle is opposite. Whoops, not opposite, is it? Looking at the picture, should look at this. Says it. Cosine, top, adjacent. Bottom, hypotenuse. Now let's get specific. Cosine of 60. Adjacent x, hypotenuse 8. Still nice. Okay. Same algebra as before then. The 8 comes up, multiply both sides. You get 8 cosine of 60, which is x. Happen to know that cosine of 60 is a half. Yes, just like sine of 30. They're kind of related. And this gives a final value of 4. In other words, the adjacent side that we're missing down here is 4. So a couple of things from here. First of all, congratulations if you stopped the video and tried it ahead of time, which is a trick, a technique you can do. I would like to point out that if we needed to do something called solve the triangle, it means find everything. And that means we would need to find this other side as well. So we could do it with trig, the last side. Could do it with trig if you want. Just be doing all this again for the opposite side. Or don't forget, we got our buddy Pythagoras there. I'm going to say Pythag is a verb, or Pythagorize. We can Pythagorize this to get the remaining side as well. And it might be easier. Okay, leave it up to you. Alright, so that's our that's the last example for this particular topic. So I hope you found it useful. I believe if you follow the steps carefully, you will be able to enjoy continued success with this particular topic. So let's move on in the next video to working with triangles. But instead of solving for sides, we're going to solve for the angle instead. You will find many similarities, and then just a couple of differences near the end. Thank you for watching. Bye for now.